Question 1 just asks for the Brunstett-Lowry definitions of acids and bases, and they're the definitions you already know. So an acid is a proton donor and a base is a proton acceptor. It's just that in the past we've kind of learnt those slightly odd definitions, but now we're going to look at the sort of theory from which they come. So if it asks for Brunstett-Lowry definitions, it's just that. And then question 2 gives you an example of a reaction to which you can apply those definitions, which otherwise might not obviously look like an acid-base reaction. So we've got calcium hydroxide, which is a solid. Make sure you get the formulae right. If you've written down CaOH, remember you should have thought about the charges on the ions. That's the key thing. Plus, and that's a solid, plus ammonium chloride, NH4 plus and Cl minus, so that's just NH4Cl, also a solid. And it tells you that gives you calcium chloride, also a solid, plus ammonia, plus water or steam, because we're heating it to make this reaction happen. So we get this in the form of steam. So that needs a little bit of balancing. So you can see CaCl2 means that you're going to have 2 here, and that gives you 2 ammonias to balance the nitrogens up. And then if you add it up, you realise that you need 2 waters as well. So that's your balanced equation. And the important thing is that it then asks you in part B to explain what's acting as the acid in that reaction. And you can see that the thing that donates a proton is the ammonium chloride, because the NH4 plus ion gives up a proton in order to become ammonia. So using that definition, the ammonium ion acts as an acid. And so using these general definitions just broadens out the concept a little bit of things that can be acids. So NH4 plus is the answer to part B. So question 3 just focuses on bases and asks us to think about 2 ions, or 2 things really, a hydroxide ion or an ammonia molecule, both of which are bases, and asks what it is that gives them that ability. And the answer, of course, is that in order to accept a proton, the way you accept it is by donating a pair of electrons to form a dative covalent bond to it. And so that's the answer. OH minus actually has 3 lone pairs around the oxygen, but it just needs 1 of them to do that. And ammonia obviously has 1 lone pair on the nitrogen there. And the answer is that both can donate a lone pair of electrons to form a dative covalent bond to H+. So that's just really looking in a bit more detail at what we mean by accepting a proton. We really mean using a pair of electrons to form a dative covalent bond to an H+ ion.